In this example, given a piping isometric, as you can see here, we will solve for the missing dimension, highlighted here in red. This unknown dimension corresponds actually to the run of the pipe. And as you can see here, the indication of the horizontal angle with the letter H is included on the isometric offset. Thus, this is a horizontal isometric offset. In this piping configuration, two 45-degree elbows are laid on their side and remain in a horizontal plane with no change in elevation. The missing dimension in our case is actually the hypotenuse of the following right triangle. Since we know the x angle, which is in our case 45 degree, then to determine the missing dimension, we only need to find out the side adjacent or the side opposite of this right triangle. In our case, given the information provided, it makes sense to look for the side opposite dimension. Why is that? Because the side opposite dimension plus 45 feet and 2 inches corresponds to the total length as highlighted here. This total length can be broken down into the following terms: the nozzle to nozzle centerline distance minus 1 gasket thickness minus the length of a 10-inch 150-pound rating gate valve minus a second gasket thickness minus the length of a 10-inch 150-pound rating 90-degree elbow. Each gasket has a thickness of 1/8 of an inch. From the sizing tables that you can find in the downloadable resource section, you can see that a 10-inch 150-pound rating gate valve has a length of 13 inch, and that a 10-inch 90-degree elbow has a length of 15 inch. So now we need to determine the nozzle to nozzle centerline distance. This dimension can be calculated using the nozzle coordinates. Take a look at the following isometric grid. We have placed each nozzle according to its coordinates. For nozzle N3, the E30 feet coordinate indicates a 30 feet distance in the east direction. The S40 feet coordinate indicates a 40 feet distance in the south direction. And for nozzle N5, the E20 feet coordinate indicates a 20 feet distance in the east direction. The N20 feet coordinate indicates a 20 feet distance in the north direction. From this figure, it becomes obvious that the nozzle to nozzle centerline dimension can be calculated by adding the north coordinate of nozzle 5 to the south coordinate of nozzle 3. Therefore, the nozzle to nozzle centerline distance is 60 feet. As a result, the total length equals the following. Now, the side opposite of the right triangle can be calculated by subtracting the 44 feet 2 inch from the total length, as seen here. This yields the following result. Okay, now we can easily deduce the pipe run by using the Pythagorean theorem. Recall, for a right triangle, the hypotenuse is the ratio of the side opposite to sine x. Substituting for the known values gives the following. But before to do the calculation, we need to convert the inches, highlighted here in blue, to decimals. We can do that by referring to the conversion chart as we have seen in the previous video. So, as you can see here, the pipe run dimension is 19 feet 0625. Lastly, since all dimensions in a piping project should be expressed in feet and inches and must be given to the nearest 1/16th of an inch, then we need to convert the decimal part of the dimension to inches. This is done by using the conversion chart in reverse.